Okay, there are many different definitions of acids or bases. The ones we're going to work with are this idea of acids are substances that add H plus to a solution. Now, H plus is really just a proton. So we can call this, oops, maybe not. Oops. So, we'll go orange. So this is also called a proton. Why is H plus considered a proton? Well, let's go back to like September. What do we know about atoms? Well, hydrogen has 1 proton. Most have 0 neutrons. And if it's positive, that means it loses an electron. Well, hydrogen normally has 1 electron. So if it loses its electron, well, now it has 0 electrons. So you also hear acids being called proton donors or proton acceptors. Those would be bases, would be proton acceptors. You'll hear acids called proton donors. It's because all H plus is a proton. Bases are substances that add OH minus to solution. So they increase the hydroxide concentration. In substances, neutral substances do not add H plus or OH minus to the solution. So in order for a solution to be neutral, the H plus concentration is equal to the OH minus concentration. So water actually breaks down into H plus plus OH minus a very little amount. Very, very, very slightly. We'll talk more about this later on, but very slightly. So these concentrations are very low in a neutral solution. Very, very low. So how do acids produce H plus? Well, let's think of a generic acid called HX. So you can generally recognize acids. We'll go back for a second. Generally start with a H. So if you're looking at a chemical formula, acids generally start with H. So HX in water breaks up into H plus and X minus. So what's really happening here is this is a covalent bond between H and X. Remember, covalent bond is shared electrons. So when this breaks apart, what happens is both electrons go to X. So H plus is left behind, both electrons go here, and that X takes both electrons, and that's how it makes an acid. So you're left with H plus in solution, and that X is holding on now to the electrons. It's just an ion in the water. Now, really what's happening here is you'll see an acid written this way as well, where what's actually happening is that H plus will react with water and make H3O plus. So if you consider H plus or H3O plus, these are H plus and H3O plus are essentially equivalent. You'll see it written both ways. So just know that you're essentially talking about the same thing. So strong versus weak acids. Acids that we say completely dissociate. And this means dissociate means 100% of the molecules break into H plus and an anion are called strong acids. Acids where only a small amount dissociate, which is to say break up, are called weak acids. Now this is going to be confusing. as we move towards calculating pH, which is a measure of the acidity of a given solution. Vinegar. Vinegar is acetic acid, weak acid. So I'll just give some examples here. An example here would be hydrochloric acid. Splits up completely, 100%. You put HCl in water, 100% splits up into H plus and Cl minus. But you take something like vinegar, HC2H3O2, well, some of it will split up into these things, but it mostly stays here. It doesn't go all the way. A small amount of it will break up. So if I put a mole of HCl in and a mole of acetic acid in, well, I'm going to get a lot more H plus from the HCl, because all of that's going to split up, whereas in the vinegar, only some of it will split up. All right, bases can produce OH minus in two different ways. The most simple way is with metal and OH minus bonded together. We call them metal hydroxides. Metal hydroxides. So in this, you have something like sodium hydroxide. So you put sodium hydroxide into water, and you get Na plus OH minus. Remember, bases increase the amount of OH in a solution. So it breaks apart like any ionic compound. So we'll say it dissociates, producing OH minus. So that makes it a base. Well, now there's the slightly more complicated way. Purple. More complicated. Which is, you take H plus away from water. There are some substances that like H plus, that like that H more than water does. So we'll have NH3 is one of them, plus water. Well, what happens is that NH3 will actually take a proton from water, producing OH minus. So that's another way that you can increase the OH concentration, is by having a base take an H plus away from water. So substances add OH by removing H plus from water. Some substances add OH by removing H plus from water. This is called the Bronsted-Lowry acid as a proton donor and a proton acceptor. Strong acids and strong bases dissociate completely into ions, while weak acids and weak bases do not.